Namaskar students. In previous video we learn subsets. Now in this video we will learn subsets of set of real numbers. This capital R is called the set of real numbers. In lecture 2 we discussed some special sets. On that way we here also the discuss N, Z, Q, T and R. Okay. In the relation of subsets. First see what is the relation. See, N is the subset of Z and Z is the subset of Q and Q is the subset of R. So N is also called subset of Q, N is also called subset of R. Z is called subset of Q as well as subset of R, and Q is also the subset of R. What is capital N? You know, capital N, the set of natural numbers, and the numbers are 1, 2, 3, 4, 5 and infinity. Okay. And what is the set Z? Z is the set of integers. Which numbers include in Z? So negative infinity, -3, -2, -1, 0, then 1, 2, 3 and infinity. So this Z contain also 1, 2, 3 and infinity, mean all this N. So N is a subset of Z. Is that clear? Then Q. What is the meaning of Q? Q is the set of rational numbers. And which type of rational numbers are there? Is the set of all x such that x is p by q. What is p and q? They are integers. And what is q? Q is not 0. Remember this thing. So which type of number belongs to Z? Like this, see, for example 5, -5. So -5 is Z, belongs to Z and as well as it belongs to Q, because -5 can be write as -5 by 1. Is that clear? Integer 3 and quotient 1 by 2 is also the rational number. How? 3 2s are 9 plus 1 11 3 2s are 9 plus 1 10 by 2 10 3 2s are 6 plus 1 7. So 7 by 2 is the rational number. 7 by 2, like this. Okay, so this is rational number. So such type of numbers belongs to Q, and also all our integers also belongs to Q. How can we write 2? Because 2 belongs to N, 2 belongs to Z as well as 2 belongs to Q. Because 2 can be expressed as 2 by 1, like that. Is that clear? So every natural number expressed as the set of as the rational numbers. Every integers can be expressed in the form of rational numbers. So N is a subset of Z, and N and Z are also subset of Q. Remember this thing. Okay. Next the set will be T. T is the set of irrational numbers. Irrational numbers. The set of all x where x belongs to R but x does not belongs to Q. So this set contain all those numbers which are belongs to R but not belongs to Q. Is that clear? And which type of numbers belongs to T? Like this, see, √2, √3, √5, √7, pi, e, all are irrational numbers. These are irrational numbers and which are belongs to T. And R is the set of real numbers. it can be write in the interval form minus infinity to infinity. R mean number line. You know the number line? You may studied in the 10th and 9th standard. Okay. So R is called the number line minus infinity to infinity, the set of all real numbers. So see, irrational number is a subset of real number because real number contain all things: rational, irrational, natural, integers, all the things. Okay. But remember, natural is not subset of irrational. Integers is not subset of irrational, and rational is not subset of irrational. Keep in mind. Okay. Now, new topic, that is intervals as subset of R. Intervals as a subset of R. So now capital R contains some intervals and they are subsets of rational numbers. Okay. So let first two real numbers and the relation, that is A is less than B. Then this notation bracket A comma B is called open interval, and the set builder form is this: the set of all x where A less than x less than B. This means x is a number between A and B, but x is not A, x is not B. So this interval does not contain end point A and B. They contain all the numbers between A and B, but not contain end point A and B. Okay. This expressed in the figure like this. Okay. A is not belongs to, so we write hollow point. Hollow point. B does not belongs to interval, so B is expressed as hollow point. But all points between them are belongs to this interval, so we write the line dark. Okay. Then next, second, this is called close interval. Close means square bracket. This is round bracket. This is square bracket. Okay. You can remember like this: open interval. Open. Remember like this. So round bracket. Okay. And closed interval. So C, square bracket. So this is also the method to remember this thing. Okay. Next, close interval, and this close interval means the set builder form is the set of all x where A less than or equal to x less than or equal to B. And this equality indicate that this point also belongs to interval, this point also belongs to interval. Mean both end point also belongs to interval and all the point between them also belongs to the interval. So we express the figure as given here. See, end point dark, middle line also dark, all are included. Okay. Then next, half open, half close type intervals. Open, close. First open, so open. Close, then close interval. So open close can be expressed as one side is open, next side is closed. So here not equality given, here equality is there. So open side is hollow point, closed side is dark point. Okay, and all the point between them are also included. So one end point A is not included, B is included, A is excluded. Okay. Then fourth is close open interval. A less than or equal to x but less than B only. Okay. So A is closed, B is open. Close open interval. Is that clear? These are some infinite intervals. minus infinity to infinity, say, are the set of real numbers, minus infinity to infinity, and always infinity open interval. When we write infinity, we have to write open interval on that side. Okay, minus infinity to 0, negative real numbers. 0 to infinity, positive real numbers. Close 0 to infinity mean positive real number, union 0, include 0 also, include 0. Okay, that's why we write here close 0 to infinity mean non-negative real number. We write here non-negative real number. These are positive, these are negative, these are non-negative. And this b minus a means the length of any of the intervals of this floor. For example, one interval is given like this 2 to 5, and we have to find the length of this interval. Then it is very clear that we have to write b minus a mean 5 minus 2 equal to 3 is called length of interval. Length of interval, length of any interval. Suppose this interval is not closed, is open, then also the formula is same. Formula doesn't change because this formula is for any interval, open, close, open, close, close, open. Is that clear? So remember all this thing. Okay, and note down. Then we will solve two questions. First, note down all the theory part. You have to write theory part 10 times. Remember, 10 times. Homework. Now, question number 6 of 1.3. Write the following questions as intervals. The questions are given in set builder form. As we noted here, this is interval form, this is set builder form. Okay, we write the relation between intervals form and set builder form. Here one form is given, that is set builder form. And we know whenever the only less than given, we write open interval, and less than or equal to given, we have to write close. See here, only less than given we write open, on less than or equal to given we write close. So very simple to remember. So what is the answer here? Tell me. What is the answer? See here, less than only, and here less than or equal to. So this is not close, but this side is open, this side is closed. So open minus 4, close 6. Okay. Here both sign is less than. So open interval, very clear. So this is open interval minus 12 comma minus 10. Okay. Then here this is less than or equal to, and this is only less than. Okay. So we have to write here close and here open. This equals to close 0 to open 7. Okay. Then here both less than or equal to, less than or equal to. So what we have to write? Both side close. Okay, both side close. So close 3 to 4. Next, write the following intervals in the set builder form. Now, intervals given, we have to write this side, set builder form. But when we write set builder form, we have to indicate x belongs to R. Why? Because these interval are infinite interval. Because there are how many elements in this interval, you know? Infinite intervals. You cannot imagine how many there, because they contain infinite numbers. So when we write here interval form, interval to set builder, we have to indicate x belongs to R. Here do not indicate because we write separately A and B belongs to R. That's why we do not write here in the theory part. But when we write in questions, we have to write answer in the form X belongs to R like that. So how to write first? First is open interval. In open we write only less than. Is that clear? So see, this equals to the set of all x where x belongs to R minus 3 less than x less than 0. This is the method. Very simple. Here close. So how to write? See, the set of all x belongs to R, 6 less than or equal to x less than or equal to 12. Okay, so I give you next two in homework. Is that clear? So this theory part you have to write 10 times, and question 6 and question 7 you have to write 2 times in homework. Okay, next, not that one.